Hello everyone, this is for section 10.2 for pre-calc, and what we're going to be looking at starting is ellipses. I'll give you the general information and then we'll do some specific examples here for you. So when you have an ellipse, if the ellipse is opening this direction or longer in that direction, it's x minus h squared over a squared plus y minus k squared over b squared is equal to 1. Just like with the other stuff we've been reading, like for parabola, you read the center for the ellipse as hk. So this would be the center of it, wherever those, I think it's obvious what center means. Okay. These are going to be the foci. Ellipse has two foci, whereas on a parabola there's only one foci. These are going to be the vertices, or it has two, there's a vertex and there's a vertex. Okay, so it has two vertices. There's going to be a thing called the eccentricity, and eccentricity is a measure of its oblateness, which is a fancy word for saying how elliptical it is or how circular it is. Okay. The distance, let me get rid of those. Those are the foci. The distance from the center to the foci is c, and the distance from the center, okay, hold on, to the vertice is a. This distance here, they're not going to ask you for it, but that's going to be the distance b. All right, so here goes. To get the foci, I've moved left and right the amount c, left and right. So when the parabola is opening this, or not parabola, when the ellipse is opening this direction, you're going to be h plus or minus c, and then k. The vertices are going to be h plus or minus a, and then k. And your eccentricity, and we'll explain a little more about this later, is c divided by a, where c is calculated as a squared minus b squared. All right, this is plus, this is minus. I'm going to point that out when we get to hyperbolas. This will be switched when we have hyperbolas. That'll be minus, this will be plus. The equation will look identical, but that'll be a minus and this will be a plus. All right. When your ellipse is long in the y direction, your equation is going to be x minus h squared over b squared plus y minus k squared over a squared equals 1. I'll explain to you a way to remember which one's a and which one's b. It's actually going to be a lot easier than perhaps what it looks like. The center is still going to be at hk. The foci, this distance up from the center is still going to be c, but you're moving in the y direction, so it's h k plus or minus c. Your vertices, this distance here all the way down is going to be a, and you're not moving left and right, so it's h k plus or minus a, and then the eccentricity is still c over a, where c is found with this relationship. Now, what's implied by a and b is size. A is supposed to be larger than b, because this would give you an imaginary answer if b was larger than a. I'll show you guys a way to get around that. Not to get around that it's a squared minus b squared, but to get around having to memorize this per se, or which one's a and which one's b is really what I'm after. So let's go and graph a couple of these. Wait a minute. Oops. Hold on. I think it's at the bottom of this one. Yes. Okay. Find the center. The center is read opposite, so it's going to be negative 3, 5. So go negative 3, 1, 2, 3, 4, 5. There's the center of your graph. From your center, square root in the x direction. So go 4 units in the x, 4 units, 1, 2, 3, 4 in the x, both ways. Then go 5 units in the y, 1, 2, 3, 4, 5. And then 5 would be down here. Which way is it longer? I think you see it. That it's longer in the y direction. So these are going to be your vertices because it's longer in that direction. So your vertices are going to be -3, 10, and -3, 0. You're just reading it right off the graph. The foci, well, they're going to be up here somewhere and down here somewhere because they're in the long direction. Now, how to draw your ellipse? Just freehand it. Try not to make it look like a diamond. Try and curve the thing as you go. Got a little flat there, but whoops, a little flat there. Okay. Just don't make your ellipse look a diamond. Okay. If for anything other than that, I'll be happy. All right. So to get the foci, c squared is a squared minus b squared. So c squared is 25 minus 16. So c squared is 9. So c is equal to plus or minus 3. So you're going to move up 3 units and down 3 units. So the foci are going to be at -3 and 8 and -3 and 2. The eccentricity, c is actually just +3 is really what this is supposed to be. So 3 over a, which is 5, so 3/5. Okay. This one, you're going to go 10 units in the x direction. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oops. I apologize. I didn't go from the center. I have no idea what I was thinking. Apparently not. 4, 3. So 1, 2, 3, 4, 1, 2, 3. There's your center. Now I'm going to go 10 right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And 10 left. So if that's 4, 1, 2, 3, 4, 5, 6. Okay. So there's going to be your centers. So again, I'm just looking to make sure that when I get to the next thing, I've got it right. Okay. So your vertices are going to be 10 left and right. So 14, 3, and -6, 3. Now, go square root of 20 in your y direction, and the square root of 20 is about, whoops, nope, that's going to be the wrong number. Sorry guys, let me pause this. I think I made a mistake and I'm having trouble seeing it. 1 sec. Okay guys, sorry for that. I was doing fine. I was, this is a bad day. I need my caffeine, I guess. Okay, so to get the distance up and distance down, that's going to be the square root of 20. So the square root of 20, 2 square roots of 5. By all means, if I ask you to write the coordinate of those, and they're going to be co-vertices, then I want you to write it with the 2 square roots of 5 in it. But I'm not asking you for that information, so to get it to be on the paper, you can use an approximation for it, which is about 4.5. And I got that by typing it in the calculator. So 4.5 units up, 4.5 units down, there's going to be the co-vertices. Okay, and now you draw your ellipse. And there you go. Okay, a little bit flat there and there, but we got the general idea going on here. Okay, the foci are going to be in the x direction. Okay, to get them, I would go c squared is a squared minus b squared. You just have to remember that you're taking the larger number first. So that would be 100 minus 20. So c squared is c is going to be the square root of 80. Getting ahead of myself there. You're not going to write it as the square root of 80, so I do need you to reduce it. So that's 16 times 5, so 4 square roots of 5. So 4 square roots of 5 units left and right of the center, so it's 4 plus or minus 4 square roots of 5, 3 would be the 2 foci. Now, to get them to be on your paper, yes, I need you to type that in your calculator and get a decimal approximation. Square root of... 1 second, let me just do it. Square root of 80. So 80 raised to the half power is about 8.9, so 8.9 units left and right. Now, you guys know that you went 10 units over, so that would be 9 units. So there's one foci, that would be 10, that would be 9, there would be the other foci. Okay. All right. The eccentricity is C, so 4, whoops, it's equal to 4. 4 squared roots of 5 over A, which is 10. So that's going to be 2 squared roots of 5 over 5. Okay. I have yet to show you a circle. 1 second. Let me pause it. Sorry, guys. I thought I had made a mistake in placing the covertices, but I'm just fine. All right. I don't have any specific examples to give you for circles, but I'll talk you through it because I think it's going to be like, really? That's all there is to it? Because really, that's all there is to it. All right. The equation for a circle is going to be just x minus h squared plus y minus k squared is equal to your radius squared. Your center is at hk, and your radius is r. So if we gave you one, I don't know, x minus 3 squared plus y plus 2 squared is equal to r squared. All you have to do is, 1 second, making sure that I don't have an actual example. I suppose I should make sure. Nope, I don't. Whoops, I should have put a number there. Getting a little scatterbrained again. Guess I should know not to do these when I'm being scatterbrained. So your vertex, or not your vertex, your center, would be 3 right, 2 down, 3 right, 2 down, and then your radius is 3. So you just go 3 units in each direction, and then draw your circle. Couldn't be any easier than that, except it's supposed to go through the points. Keep in mind that as they're doing this to you, that they could give it to you like this. So if I were to get rid of this graph so I could make it a little more obvious what I'm trying to explain here, hopefully a little more obvious. This is 9. If I were to take it, divide by 9 on everything, then you got x minus 3 squared over 9 plus y plus 2 squared over 9 is equal to 1. They could give it to you like this, but what you should recognize is initially you might think it's an ellipse. Okay, so you go to 3, negative 2, and then you go 3 units in the x direction, so out here, but then you go, wait a minute, I have to go 3 units in the y direction. Your radius isn't 1, but you've already got the radius. The radius is already there by initially thinking the poor thing's an ellipse when it's really actually a circle. Okay? There won't be foci on this then. Okay? So, there you go. That's one thing to watch out for when they're doing that. So, there you go. Circles and ellipses.